So, good afternoon, everybody. Myself, Acharya Vishvendra, and today I shall be discussing some worksheets on temperature scales. So, let's begin with the worksheet. So, here is the worksheet on temperature scales, and the first question is name some temperature scales. So, some temperature scales are centigrade scale, Fahrenheit scale, Kelvin scale, and Reaumur scale. Next question is on what property of material thermometers are designed. So thermometers are the instruments used to measure temperature, and they are based on some linear property of matter like length of mercury column, or the pressure of gas, or the volume of gas, or the resistance of platinum thermometer. Next is we need to fill in blanks. I have already filled them up. Like there are four scales: centigrade, Fahrenheit, Kelvin, and Reaumur. So the lower scale for centigrade is 0 degree centigrade. For Fahrenheit it is 32 degree Fahrenheit. For Kelvin it is 273.15 Kelvin. For Reaumur it is 0. Similarly for upper scale, centigrade scale corresponds to 100 degree centigrade. Fahrenheit corresponds to 212 degree Fahrenheit. Kelvin corresponds to 373.15 Kelvin. And Reaumur corresponds to 80 degree Reaumur. Now talking about the number of divisions, so you just take the difference of these. So here it comes out to be 100 for centigrade scale, for Fahrenheit 180, for Kelvin 100, and for Reaumur 80. Next is which scale has lowest scale reading or minimum scale reading, so it is for centigrade and Reaumur. Next is which scale has highest upper scale reading, so it is for Kelvin. Next is temperature of a body changes by 2 degrees centigrade, then we need to find change in degree Fahrenheit. So we know the relation is delta Tf is equal to 9 by 5 times delta Tc. So delta Tc here is 2 degrees centigrade. So delta Tf will be 9 by 5 into 2. After solution it comes out to be 3.6 degree Fahrenheit. Then we know that delta Tk is equal to delta Tc, which will be 2 Kelvin. Then we have the relation that delta Tr is 4 by 5 times delta Tc. Delta Tc here is 2, so delta Tr will be 1.6 degree Reaumur. Then next question is at what temperature Tf is equal to Tc, that is reading of centigrade and Fahrenheit scale will be equal. So using the relation between Tf and Tc, the answer comes out to be minus 40 degree centigrade or minus 40 degree Fahrenheit. Next question is at what temperature Tc is equal to Tk. So we know that Tk is equal to Tc plus 273.15. So here I write Tc, so it equates that 0 should be equal to 273.15, which is never possible. Next is at what temperature Tf is equal to Tk. So we use the relation that Tf minus 32 by 180 is Tk minus 273.15 by 100. So after the calculations, Tk comes out to be about 574.5 Kelvin. Next is at what temperature Tr is equal to Tc. So by substituting the equation, we have 0 as the point. Next is if 60 degree centigrade is x degree Fahrenheit, we need to find x. So using the relation that Tf is 32 plus 9 by 5 Tc, we take Tf as x and Tc as 60. On calculations, x comes out to be 140. Then in another question, 60 degree centigrade is y Kelvin, we need to find y. So using relation Tk is equal to Tc plus 273.15, we get y as 333.15. Then in another question, 60 degree centigrade is z Reaumur, we need to find z. So we know that Tc is 5 by 4 Tr, which implies 60 is equal to 5 by 4 z, which implies z is 48. Next we have to find a relation between difference in temperature and different scales. So we get delta Tc is equal to delta Tk is 5 by 4 delta R, which is 5 by 9 times delta T. So these are the basic worksheets just prepared to optimize your time and energy. Thank you and have a nice day.